So for intersecting lines, which are these, when they intersect, they cross at one point. That point is your solution. If you look at both of these lines of the equations that I kind of made up to go with it, they have different slopes. They could have the same y-intercept, but they have to have different slopes so they could actually cross. So if your equations have different slopes, you will get one solution. So this is why when it says describe the relationship between the two lines in graph A, I pointed out that they have to have different slopes, and that means that they will intersect exactly one point. Well, how many solutions does it have? Exactly one solution, because they only cross at one point. If we're looking at the parallel lines here, parallel lines never cross, and parallel lines have the same slope and different y-intercept. This is why I wrote down that the two lines have to have the same slope and different y-intercept. That means they're parallel. Parallel lines have no solution. That means they have no answer. Okay, and then we have coinciding lines, which basically means that they're the same line. So this purple line and this red line, they're basically the same equation. If they're the same equation, then both lines are touching at every single point. That means they have infinite many solutions. To be coinciding lines, they have to have the same slope and same y-intercept when you put them in slope-intercept equation. And they have infinite many solutions. So when we're doing a solving system of equations, if you notice, both of these equations are in standard form. So our first step is to write the both equations in slope-intercept form, which is y equals mx plus b. So what I like to do is I like to number them. This is equation 1 and equation 2. So for equation 1, I need to get solved for this y right here. So the first thing I'm going to do, it's add its opposite, the stuff that we've been doing for the past 2 months. The 2's go away, and since these two are not like terms, you're going to put them right next to each other, and this now it's in slope-intercept. And we're going to do the same thing for equation 2 right here. So that means equation 2 is negative x plus y equals 3. I'm going to solve for y, get that y by itself. So that means I'm going to add x to both sides. This x goes away, and my new equation is going to be y equals x plus 3. For my second step, I'm going to graph both equations, but first I'm going to identify the slope, which is the m, and the y-intercept, which is the b, for both the red and the green equation. For my red equation, my b is 6, is always my constant, so I have 6. My slope is always a number in front of my x, which is negative 2. But my slope should be a fraction, so it gives me directions to my next point. So I'm going to, my rise is negative 2, and my run is 1. Remember, you always plot this point first. And this, I did the same thing for my green equation. My y-intercept was 3, and my slope was 1 over 1. So when I graph my red equation, this is 6. I go down 2 over 1, down 2 over 1, down 2 over 1, and I make my equation. I numbered it. I did the same thing for the green equation. I started at 3, went up 1 over 1, up 1 over 1, and they intersected at this point. That intersection is the one solution for this equation. I have to figure what the number is. So it intersected at 1 and 4. So 1 for x and 4 for y. So that means my solution is 1, 4.